Welcome students. Myself GB Patel, lecturer in Mechanical Department, VPMP Polytechnic. The subject name is Thermodynamic. The subject code is 3331902. Today we are going to discuss the reversed Carnot cycle. The objective of this video is to derive the coefficient of performance of the reverse Carnot cycle. So let us understand reverse Carnot cycle on PVTS diagram. So this is the reversed Carnot cycle. Here you can see there are four processes: 1 to 2, 2 to 3, 3 to 4, and 4 to 1. 1 to 2 is a reversible isentropic process. You can see here 1 to 2 is a reversible isentropic process, and it's also a compression process. So compression work is done on the cycle. Okay. Reversible isentropic means adiabatic process. Here 1 to 2 is reversible isentropic process, hence it's a reversible adiabatic process also. 2 to 3 isothermal process, reversible isothermal process. During process 2 to 3, heat is rejected, QR is equal to QK. So sometime heat rejected is referred as QR, sometime it's also referred as QK. So in our case we are preferred heat rejected is QK. Okay. Process 3 to 4 is again reversible isentropic process, means reversible adiabatic process. You can see same process on the PV diagram. 3 to 4, it's an expansion process. So 3 to 4 is a reversible expansion process, adiabatic process. And 4 to 1 again temperature constant isothermal process. The heat is absorbing during process 4 to 1. Sometimes it's referred as a QA or Q0. In our case, we are consider absorbing heat as a Q0 and heat rejecting is a QK. So there are four processes: 1 to 2 reversible adiabatic or isentropic process, 2 to 3 reversible isothermal process, 3 to 4 reversible isentropic process or adiabatic process, 4 to 1 reversible isothermal process. During 1 to 2 work W compression is done on the system. During 3 to 4 expansion work is delivered from the cycle. Q rejected during process 2 to 3, Q absorbing during process 4 to 1. And as we know, for any cycle, summation of heat is equal to summation of work. Here you can see two heat interaction in this cycle. So it's a QK and Q0. So QK minus Q0 is a sigma Q. And you can also see there are two work interaction, W compression and W expansion. So sigma W is equal to W compression minus W expansion. It's also referred as W net. So COP, coefficient of performance. The definition of COP, coefficient of performance, is equal to desired effect divided by W net. So we have a two type of a COP. One is COP of refrigeration and another is COP of heat pump. So COP of refrigeration is defined as ratio of cooling effect to W net. So in this case, cooling effect is considered as Q0. Okay. So COP of refrigeration is equal to cooling effect divided by W net. So cooling effect is Q0 divided by W net. So Q0 divided by W net is equal to QK minus Q0. You can see here WC minus W compression is W net, and that is QK minus Q0. So Q0 divided by QK minus Q0, say equation number 1. COP of heat pump is defined as ratio of heating effect divided by W net. So in this cycle, QK is considered as heating effect. So it's a QK divided by W net. So QK divided by QK minus Q0, W net is QK minus Q0. Now let us consider the process number 1 to 2. Process number 1 to 2. It's a reversible isentropic process. Reversible isentropic process means adiabatic process. So for adiabatic process, we can write Tv raised to gamma minus 1 is equal to constant. That is why T1 V1 raised to gamma minus 1 is equal to T2 V2 raised to gamma minus 1. So take T1 on the right hand side and V2 raised to gamma minus 1 on the left hand side. We can get T2 divided by T1 is equal to V1 divided by V2 raised to gamma minus 1. Say equation number 3. Similarly, consider process 3 to 4. This is 3 to 4. It's again reversible isentropic process. Reversible isentropic process means adiabatic process. So for adiabatic process, you can write Tv raised to gamma minus 1 is equal to constant. Here process is 3 to 4. That is why we can write T3 V3 raised to gamma minus 1 is equal to T4 V4 raised to gamma minus 1. Take T4 on the left hand side and V3 raised to gamma minus 1 on the right hand side. We can get T3 divided by T4 is equal to V4 divided by V3 raised to gamma minus 1. Say equation number 4. But T2 is equal to T3 and T1 is equal to T4. How? Let us see. You can see process 2 to 3 is a reversible isothermal process. That is why temperature remain constant. That is why T2 is equal to T3. You can say T2 is equal to T3. And similarly, T1 is equal to T4. Why? Because process 4 to 1 is again isothermal process, reversible isothermal process. So T2 is equal to T3 and T1 is equal to T4. So see the equation number 3 and equation number 4. T2 is equal to T3 and T1 is equal to T4. You can see here T2 is equal to T3 and T1 is equal to T4. So T2 is equal to T3, T1 is equal to T4. So left hand side of the equation 3 and equation 4 both are same. Hence equation 3 is equal to equation 4. You can see here left hand side of equation 3 and equation 4 both are same. So we can say equation 3 is equal to equation 4. That is why T2 by T1 is equal to T3 by T4 is equal to V1 divided by V2 raised to gamma minus 1 is equal to V4 divided by V3 raised to gamma minus 1. So consider last two step. V1 V2 raised to gamma minus 1 is equal to V4 V3 raised to gamma minus 1. So gamma minus 1 get cancel on both sides. So we can get V1 divided by V2 is equal to V4 divided by V3. Here V1 divided by V2 is equal to V4 divided by V3. Say equation number 5. Now consider the process 2 to 3. Process 2 to 3. Reversible isothermal process. So QK is rejected during this process and the equation of heat interaction during isothermal process is this. QK is equal to RT2. Why T2? Because here is the temperature is T2. You can consider T2 or T3. Okay. So I consider T2 because T2 is equal to T3. So RT2 ln V3 divided by V2. RT2 ln V2 divided by V3. Say equation number 6. Similarly, consider process 4 to 1. It's again isothermal process 4 to 1 and heat is absorbed, Q0 is absorbed during this process. So heat interaction during this process is Q0 is equal to RT1. Why T1? You can see here it's a T1 temperature. You can also write T4. Why? Because T1 is equal to T4. I put here that T1. So Q0 is equal to RT1 ln V1 divided by V4. Say equation number 7. Substituting the value of equation 6, this QK, and equation 7, this Q0, into equation 1. What is equation 1? This equation. COP of refrigeration, which is Q0 divided by QK minus Q0. So from equation 6 and 7, we can put the value of Q0 and QK in equation 1. So we can get COP of refrigeration. This is the value of Q0. RT1 ln V1 divided by V2. RT1 ln V1 divided by V4. And this is the value of Qk. RT2 ln V2 by V3. RT2 ln V2 by V3 minus again Q0. This. So RR get cancelled from all the step. Ln V1 divided by V4, ln V2 divided by V3, ln V1 divided by V4 get cancelled. Why? Consider equation number 5. So this is the equation number 5. V1 divided by V2 is equal to V4 divided by V3. So V1 divided by V2 is equal to V4 divided by V3. So take V4 on the left hand side and V2 on the right hand side. We can get V1 divided by V4 is equal to V2 divided by V3. So V1 divided by V4 is equal to V2 divided by V3. So V1 divided by V4 is equal to V2 divided by V3. Both are same. So I can cancel it out. Okay. So what is remain? T1 divided by T2 minus T1 only. So COP of refrigeration is equal to T1 divided by T2 minus T1, at where T2 is greater than T1. T2 is higher temperature than T1. Okay. You can write instead of T1, T4 and instead of T2, T3. Why? See the TS diagram. T1 is equal to T4 and T2 is equal to T3. So you can also write this. Instead of T1, I can put T4 and instead of T2, I can put T3. So COP of refrigeration is T1 divided by T2 minus T1. Obviously T2 greater than T1. Similarly, substitute the value of equation 6 and equation 7, these two, Q0 and Qco, in equation 2. What is equation 2? Let us see. Okay. COP of heat pump. So COP of heat pump is Qk divided by Qk minus Q0. So put the value of Qk minus Q0 from the equation number 6 and 7. So we can get, this is the value of Qk. This value RT2 ln V2 by V1, sorry, V2 by V3 divided by, this is again value of Qk and this is value of Q0. Q0 is this RT1 ln V1 divided by V4. So as we see, V1 divided by V4 is equal to V2 divided by V3. So R get cancelled from all these steps, and ln V2 divided by V3, ln V2 divided by V3, ln V1 divided by V4 get cancelled. So what is remain? T2 divided by T2 minus T1. So this is the COP of heat pump. T2 divided by T2 minus T1. T2 greater than T1. Instead of T2 I can put T3. Instead of T1 I can put T4. So these two is the COP of, this is the COP of refrigeration. This is the COP of heat pump. Thank you.